Hello all, good morning. This is Dr. S. Subalakshmi, an assistant professor at the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Matrices and Calculus, and now we are on to the DT lecture video on the topic characteristic equation and eigenvalues and eigenvectors through design thinking. So this video is a problem solving framework for engineering mathematics. The DT lecture video is based on the 5 basic steps which is empathizing, defining, ideating, prototyping and testing. So firstly we are going to empathize the statement of the problem which is the students often struggle with abstract concepts in linear algebra. In algebra the students always used to struggle with the abstract concepts, the basic concepts of linear algebra. Eigenvalues or eigenvectors are key in vibration analysis, stability of systems, data compression and PCA, which is in the mechanical stream. We can note that in vibration analysis it is used, in the electrical stream which is used in stability of systems, and in computer science and artificial intelligence stream we can note that it is applied in the data compression and PCA. The real challenge is to connecting this matrix theory with the help of real world applications. Now, the problem is to define the problem statement. Now, we have learned what is the problem or the connection between the two things, the matrix and the real world applications, and now we are going to find or define the problem statement. So, we are going to consider the two problems here. We are going to find the characteristic equation and the eigenvalues of the given matrix A here. The given matrix A is the first row will contain 4 and 1, the second row will contain 2 and 3. Now problem 2, which is to determine the eigenvectors corresponding to the eigenvalue, to each of the eigenvalue. So how many eigenvalues will be there? Since it is a 2 cross 2 matrix, we will have 2 eigenvalues, and for 2 corresponding eigenvalues we will have eigenvectors. What is the need of this particular system? The need is a systematic step-by-step process to reduce the confusion between the matrix application in the real-time application. Now the third step in design thinking is to ideate the possible approaches. How we are going to approach the real-time applications with the matrix theory. We are going to just expand the determinant, which is a minus lambda into I, which is equal to 0. We are going to expand the determinant a minus lambda I, which we have already seen in the previous videos. We use the algebraic manipulation to solve for lambda, which we have already discussed in the previous videos, and we are going to substitute eigenvalues back into the determinant. The determinant inside we have an element, no, that thing we are going to substitute, and we are just supposing it to be 0 to find the eigenvectors. We will have this eigenvector here, we have a vector x, that particular vector x to be substituted here and find the vector corresponding to each of the eigenvalues. And most of the cases we can use MATLAB or Python or calculator as alternatives. Now, prototyping. What do you mean by prototyping? We will be calculating the known values or the formulating the values here. For problem 1, in matrix A, we will have the characteristic equation to be determinant of A minus lambda I, which is equal to 0, wherein we will have this lambda square minus 7 lambda plus 10 is equal to 0. On solving this, we will have the values of lambda to be 5 and 2. On solving this, we will have the values of lambda to be 5 and 2. So this is what the prototyping for the two of the problems here, which is problem 2 for eigenvectors. We will have lambda is equal to 5 means eigenvector is 1 comma 1, and for lambda is equal to 2 means eigenvector is 1 comma minus 2. What we infer from this? We verify the results by checking Ax is equal to lambda x, and you students have to discuss did they get the same eigenvectors. For two of the eigenvalues, we are getting the same eigenvectors or not, you have to discuss on it, and where did the mistakes happen or the signs and determinant happen. So this is what we are going to infer. So where did the mistakes occur, that is the thing you are going to infer or you are going to find. And how could this computational tools cross-check the answers? Computational tools like MATLAB and calculators and the coding knowledges, Python programming, how could we cross-check with the coding languages? This is what you students are going to explore. And the reflection of the real world link for the particular eigenvalue and eigenvectors. Firstly, eigenvalues determine the system stability. In mechanical and electrical fields, you know about system stability. A particular system is chosen. If a particular system is chosen, we can note the stability of the particular system chosen using eigenvalues. Eigenvectors indicate the directions of maximum influence. So eigenvectors are nothing but both which have magnitude and direction. So it indicates the directions of maximum influence, means which direction the particular system is running on. And it is also applicable in structural engineering like resonance analysis, artificial intelligence and machine learning, and the principal component analysis. And in electrical engineering we have in network stability. So basically the eigenvalues and eigenvectors are stability understanding concepts. And on conclusion, the design thinking helped us to empathize, define, ideate and prototyping, testing the modules of the methods considered and the struggles we found. So this is what we have learned, design thinking approach on the eigenvalues, the eigenvectors using the characteristic equation. We will have one more video on the case study of eigenvalues and eigenvectors. Thank you.